Okay, a quick review of graphing quadratics in standard form. We got one more application problem I wanted to go through with you guys. So here we've got a person standing close to the edge on the top of a 224-foot tall building, throws a baseball vertically upward. And so the baseball is going to rise vertically and then come right back by him and continue on falling down towards the ground below the building. The quadratic function S of t equals negative 16t squared plus 64t plus 224 is what models the ball's height above the ground, which is going to be S of t, as a function of t, which is the number of seconds after it was thrown. So we want to answer a couple questions here. After how many seconds does the ball reach its maximum height, round to the nearest tenth, and then what is the maximum height? Okay, so I talked with you folks the other day about how important it is to think about graphs in terms of, or think about functions in terms of what the graphs might look like. My input variable is t and my output variable is s. So if I were going to graph this, this would be the s-axis and this is the t-axis, right? Now this is a quadratic equation with a negative value for a. And so we can see that this is a function that's going to produce a parabola that opens down, right? So we can see then that the vertex of this parabola up here, coordinates hk, are going to give me h as a value of t. So that's going to be the time when the ball is at its maximum height, and k is a value of s. So that's going to be the maximum height at that time. So that's all we've really got to do here is find the vertex, right? Well, we've got the equation. If we go back on the slides, we've got this equation, h equals negative b over 2a. And then to find k, we just evaluate the function at h, right? So if we apply that formula, we can see that a is negative 16, b is 64, and c is 224. So this just gives us negative 64 over 2 times negative 16. Well, that's just negative 64 over negative 32, which is positive 2. So we know then that the time it takes to get to the peak of the flight is 2 seconds. And if we want to know how high it goes, well, we just plug that back into the function, right? The maximum height is just going to equal s of 2, which is negative 16 times 2 squared plus 64 times 2 plus 224, which gives us what? Negative 64 plus 128 plus 224, which is just going to be 288. So that's the maximum height, 288 feet. Okay. Now we're jumping into something a little bit new for today. The topic for the day is converting standard form to vertex form. And there are going to be 2 ways that we can do that. Oops, give me just one quick sec. I think I wasn't recording there, so I got to back up just a second. So a quadratic trinomial in standard form just looks like, as we've talked about, that just looks like ax squared plus bx plus c. F of x equals ax squared plus bx plus c. It's quadratic. It's a trinomial because it has 3 terms. And a quadratic trinomial is a perfect square trinomial if, am I recording? Yeah. If half of b squared is equal to the product of a and c. Okay, here are some examples of perfect square trinomials. Now, we're jumping forward just a little bit here, and you kind of have to do this with Algebra 2 a little bit. We're going to come back and review factoring, like I said, here in the fairly near future. But let's just get a glimpse forward into that process. You've done a lot of this, so this is review for you. Remember that when we're factoring a quadratic trinomial, where a is equal to 1 especially, we just want to find magic numbers that multiply to the constant and add to the coefficient of x, right? Well, in this case, 4 times 4 is 16 and 4 plus 4 is 8. So this is going to factor into x plus 4 squared. Look at the conditions. Half of b is 4. 4 squared is 1 times 16. So it meets this criterion up here, doesn't it? Okay. What about this guy right here? Well, this fits also, doesn't it? Because b is negative 18, a is 1, c is 81. Half of b is negative 9. Negative 9 squared is equal to 1 times 81, right? And this one factors into x minus 9 times x minus 9. Here, half of 2 is 1. 1 squared is 1, which is equal to 1 times 1. So we get a plus 1 squared. And here we get p squared minus 10p plus 25. So b is negative 10. Half of b is negative 5. Negative 5 squared is 25, which is equal to 1 times 25. And this factors into x minus 5 squared. Let's see if we can make a connection here on all these examples of factoring that we did. I want to do this pictorially. If we look at this, let's look at this first example, x squared plus 8x plus 16. I can break this up into shapes, right? I could do something like this. I could say something like, if I call this dimension x and that dimension x, and I call this distance, that's then the total area of this would just be x squared.
Is you recording?
Yeah. Okay, back to it here. So, right, so this corresponds to the first term in the trinomial. The 8x, well, we already said that dimension is x, so that's x, let's call that 8. Then that area is 8x. And then this one would just be like 4 by 4, so it's half of that width. Okay, and we can take those 3 pieces and add them together to get this area. Okay, now the challenge is, can we find a way to slice and dice this stuff and piece those 3 parts together to create a square? We want to create a perfect square, right? Right now, that's not a square. Well, what if we were to split this one in half, put 1 piece there and 1 piece down there, right? So then here's our x and our x, and then half of 8 would have been 4, and that's an x. And then that's x, and then there's a 4, right? Because we cut this dimension 8 in half. And then look what fits down here in the corner. I've got my 4 by 4 piece. And so you can see that when this is true, when half of b, which is this, the width of this middle piece here, when half of that is equal to a times c, which in this case is just 16, right? 1 times 16. Then we end up getting a perfect square. We're capable of making a perfect square by just slicing and reconfiguring the 3 figures as we did. Okay, we're going to come back to that. And this seems a little out of place, but we're going to take advantage of this relationship. This is one of 2 ways that we have to convert standard form quadratic functions to vertex form. Okay, the easy way is the way that you've probably already thought about. We could just figure out what h and k are, and we already know what a is, and then we could just write it in the form a times the quantity x minus h squared plus k, right? Well, we can see up here that in this case, a is equal to 1, b is equal to 6, and c is equal to 5, right? And so we can calculate h. h is equal to negative 6 over 2 times 1, which is -3. K is going to be f of h, which is the quantity -3 squared plus 6 times -3 plus 5, which gives us 9 minus 18 plus 5, which is -4. So we get our vertex has coordinates -3, -4. Okay, we can take that information. We know what A is, we know what H and K are. And so we could write our function using our vertex form template. Got a 1 out front times the quantity x minus -3 becomes x plus 3 squared plus -4. That is a quick and easy way for us to write a quadratic function in vertex form. Okay, let's practice once real quick. So here we'll just identify what are our values of A, H, and K. A is -2, or sorry, A, B, and C. This is in standard form, isn't it? B is 20, and C is -46. So H is equal to -B, so -20, over 2 times -2. So -20 over -4 is +5. K is just what we get when we evaluate our function at 5. So that's -2 times 5 squared plus 20 times 5 minus 46, which gives us -50 plus 100 minus 46, which is +4 this time. And so we get our vertex is 5, 4. And so now we can use the fact that we know H and K to write our quadratic function in vertex form. So when we plug these values in, we get -2 times the quantity x minus 5 squared plus 4. Okay? All right, well, we can also do this by this taking advantage of this process of completing the square. Only this time, what we're going to do is we're going to take the first 2 terms. We don't necessarily start off with a perfect square trinomial, right? But if we had only started off with the blue and the red terms, we could have figured out what would be the size of the extra square that we need to add to create a perfect square trinomial that we can reconfigure as a square, right? And we know what the formula is. We know that in order for that to happen, b over 2 squared has to equal a times c, right? Okay, so if we start off with something then, if we just start off with the first 2 terms, the x squared plus bx, we already know that we could reconfigure that to look almost like a square. It's going to be like a square missing that one little small square portion in the corner, which is always going to have dimensions b over 2 times b over 2, right? Because the width and the height of that square is determined by half of the width of our rectangular piece, okay? All right, so that's the trick we're going to use, okay? We're always going to try to algebraically put ourselves in a position where we get an x squared plus bx by itself, and then we can complete the square by adding the correct amount to create a perfect square trinomial, which is half of b squared, okay? All right, so in your notes, they give you some directions for this. They're not very good. I'm going to show you a better way to do this. Here's the way we want to do this one. The easiest way to do this algebraically is to just isolate the x squared plus bx portion of the equation on one side of the equal sign and just push everything else to the other side to get it out of the way. And then we can just reverse those steps to put things back in order at the end. And you'll see what I mean when we go through an example. So the steps, once again, if it's not in the form of an equation, we want to set this equal to y, first of all, okay? And now ours are going to be in the form of equations because we're talking about f of x equals a function, right? We'll replace the f of x with a y just to make things look simpler. So using algebra, we want to make the right side of the equation, and it could be the left, it doesn't matter which one, we'll just say the right, look like x squared plus bx. We're going to have to push some things over to the left side potentially to make that happen. Then we're going to complete the square by adding b over 2 squared to both sides of the equation. You have to treat both sides equally. That's going to make the right side a perfect square trinomial, which we can easily factor. And then we're going to reverse everything to isolate the y, and we're done. Let's look at an example. Why is it in there twice? I don't know. We'll come back to that one. Okay, so let's complete the square here then. So this one is already set equal to y. It could be f of x, doesn't matter. X squared plus 6x plus 5. We already did this one, but we'll go ahead and go through it again. Okay, so what's our first step? Okay, first step. Oh, you know what? I'm going to skip this. I want to do it this way. Let's do it this way. So our first step is to set it equal to y, already done. Okay. Next step, we want to make the right side of the equation look like x squared plus bx. Well, x squared plus bx is going to be just this portion right here already, isn't it? There's x squared plus bx because a is equal to 1, b is equal to 6, and c is equal to 5 in our case, right? So to do that, we have to get rid of the 5. So we're going to store the 5 on the other side. We'll just subtract 5 from both sides. So we get y minus 5 equals x squared plus 6x, which looks like x squared plus bx, right? Okay, now what? Now we're going to complete the square by adding just the right amount to both sides to create a perfect square trinomial. Well, the right amount is half of b squared. B is 6. So half of b is 3. Half of b squared is 9, right? So we're going to add half of b squared to both sides, which is 9. If we factor the right side, look what we get. Well, we already know what we're going to get. We're going to get x plus half of b quantity squared. So there's a connection here. Whatever number is being squared, here is the number that's going to be attached to x in our binomial factor that's being squared, right? Okay, so now all we have to do in our last step is just algebraically isolate the y, which in this case means we're just subtracting 4 from both sides. So we're just reversing our operations. And we end up with our answer in Vertex form. Okay? I got to remember, it's been a couple days since I built this thing. What was I doing here? Oh, okay, those were just the same steps, but they just didn't have, we'll just skip that. Okay, let's try another one. How about this other example that we did? Okay, so first, it's set it equal to y. We want to write it as an equation, so it's already done. Now we've got to make this look like x squared plus bx. Well, there's a couple things I've got to do. I'm going to have to get rid of a constant, but I've also got a coefficient of x that I'm going to have to divide away. I have to do this in the appropriate, I want to be doing this by reversing order of operations though, because I'm essentially trying to isolate something, right? So the first thing we have to do is add 46 to both sides to get rid of that 46, right? Because we're just working bottoms up on our order of operations tree here. doing that, right? So we're going to add 46 to both sides. And then I've got to divide each side through by -2 because I need this to look like x squared by itself plus whatever number is left times x. So if I divide each side by -2, I can just leave it as y plus 46 over -2 on the other side. I don't need to get fancy and simplify because remember, at the end, I'm just going to reverse all these operations anyway. So if I divide the right side by -2, I'm just dividing each term by -2, which gives me positive x squared plus 20x divided by -2 would be -10x. Okay, now we've got to complete the square, right? We set this thing up where we've got x squared plus bx by itself on the right. So now we're going to figure out what is half of b. Well, half of b is -5 because b is -10, right? And by the way, when I say what's half of b, don't confuse this b in step 3 with the a, b, and c that we started with, right? They're different things. At the beginning here, when we had this quadratic function written in standard form, a is -2, b is 20, c is -46. It's a little confusing, but that's different than the b we're talking about when we're completing the square, okay? So when we say b in this context in steps 2 and 3, we mean the coefficient of x. Well, half of the coefficient of x is, here, whoops, give me one sec here. Okay, so you gotta think where I was here. So half of the coefficient of x, -10, is -5. So I'm gonna add -5 squared to both sides, right? I could write this as 25, but it's almost easier not to at this point on the right side because it tells me -5 is what I'm attaching to my x. So I already know without even thinking about it, I know that the right side is going to factor into the factor x minus 5 quantity squared, right? Because I know there's that connection right there. Okay, so all I've got to do then now is re-isolate the y. And I'm going to reverse my steps. Well, to isolate the y, the first thing I would have to do, there are implied parentheses around the top and the bottom of this fraction, right? So the first thing I would do is subtract my 25. -5 squared is 25. So I subtract the 25. Then I would have to multiply by the -2, of course, because remember, I've got implied parentheses around this guy. And if I'm reversing my order of operations, we took care of the addition. Now we got to take care of undoing the division. We don't get to parentheses until the top, right? So we multiply both sides by -2. And if I distribute the -2, I'm not distributing the -2 inside of this quantity that's being squared. I can't do that. I can't distribute into a quantity that's being taken to a power, but I can distribute it times that quantity, right? I've got these two terms. I've got the x minus 5 squared term, which is my first term, minus 25, that's my second term, and I'm just going to distribute that -2 to both terms. So I end up with -2 times the quantity x minus 5 squared plus 50. And you can see where we're going with this, right? We're trying to put this into vertex form anyway. So we want to have a times the quantity x minus h squared. And then finally, I just subtract 46 and I get 4. So there's my answer, right, in vertex form. Okay, why would we do this, you might ask? Why would we go through this hassle when we could just use the h equals -b over 2a and evaluate the function at h to get k? Well, actually, you're going to find that it looks like a lot of steps, but once you practice it a little bit, it's no harder and maybe even easier. But there's another reason for this, and that is that this is a technique, completing the square, that we're going to leverage next unit as one way of solving quadratic equations. So I'm showing it to you now because it has a context in what we're talking about, but also because you're going to see it again, and so you already will understand it when we get there. It's kind of a double whammy. So maybe we'll just go through a couple practice ones and we'll call it quits. So what about this guy here then? Let's just think about the steps on this. So step one, we want to write this as a y. That seems like a minor one, but f of x just looks visually, there's just more going on there. We want to make things look as simple as possible when we're doing mathematics. And it may not seem like a big deal, but I promise you, when you get into higher level math and things start to look really mathematically dense, all those little tricks, they make a difference. So we get step one is y equals negative 1/2 x squared minus 4x minus 5. Okay, now what? Well, we got to get we have to get x squared plus bx on the right side, something of that form. So we got to get rid of this extra term. We're just going to add 5 to both sides. Okay, so we're going to get rid of that guy. We're on our quest to get x squared plus bx on the right side. So that leaves us with y plus 5 equals negative 1/2 x squared minus 4x. Okay, now what? Now I've got to turn this into an x squared plus something, which means I have to undo multiplying by negative 1/2. Well, I undo multiplying by negative 1/2 by dividing both sides by negative 1/2, but we don't divide by fractions. We just multiply by reciprocals, don't we? So I'm just going to distribute a negative 2 through both sides. And that's going to give me on the left side, well, I just get negative 2 times y plus 5. Now I can distribute that, but why would I, right? I mean, I could, it's fine, but I'm just going to undo everything anyway. On the right side, when I distribute, I'm going to get a positive 1. Negative 2 times negative 1/2 gives me positive 1x squared. Negative 2 times negative 4 is going to give me a plus 8x. Okay, that's looking good. So now, and you might, you might be thinking, and this is fine. Maybe in this case, because it's so easy to simplify, maybe we do just want to make this a negative 2y minus 10. That's okay to do. What are we going to add to both sides? Well, we have to identify what b is. B is equal to 8, so b over 2 equals 4. Therefore, we know that b over 2 squared is going to be 16, right? So we're going to add to both sides a b over 2 squared, so a 4 squared. And that's going to give us on the left side, if I combine all these terms, I get negative 2y minus 10 plus 16 is just negative 2y plus 6. Now what about over here? Well, I already know that I'm going to get x plus half of b is going to be what was combined with x. Well, half of b was a positive 4, right? So I'm getting x plus 4 squared. And I could just think magic numbers, but I don't even have to. I don't even have to turn this into a 16 and then factor it. I already know that the number that's going to get attached to x in this binomial is the number that is being squared. Okay, then last step is I just want to isolate the y. Okay, well, we can just subtract 6 from both sides and get negative 2y equals x plus 4 squared minus 6. And then I'll just divide each side by negative 2, which happens to be the very same thing as multiplying by negative 1/2, right? However you want to think about it. We can do it this way if we want to. And so we end up with y, which we could call f of x if we wanted, is equal to, let's make this term, let's write it in the form a times the quantity x minus h. So instead of dividing by negative 2, we'll make that a negative 1/2 times the quantity x plus 4 squared. And then minus 6 divided by negative 2 is going to give me a positive 3 at the end. And so we're there. Maybe let's do, Yeah, this is, okay, let's do one like this too. This is probably a good one because it doesn't work out quite as nicely. These previous examples have all worked great because B has always been even, right? So half of B ends up giving us an integer, which is nice. It doesn't have to work out that way though. Let's look at this guy here. So here's one where we're trying to convert this into vertex form. So we're going to start off by setting it equal to y, right? Okay, now we've got to get on the right side, we need an x squared plus bx. First, we've got to add 22 to both sides. Cancel that. And we get y plus 22 equals negative 2x squared minus 10x. That's got to be an x squared. So we're going to have to get rid of that coefficient of x squared by dividing it away from both sides. And so I get y plus 22 over negative 2. I don't have to simplify that. And then over here, if I split this into two terms, I'm going to get x squared, what, plus 5x. Okay, so now we can see that I've got x squared plus bx over here, where b is equal to 5. So b over 2, in this case, is equal to 5 halves. So I've got to add b over 2 squared to both sides. Let's do that. And the right side looks like it might be hard to factor, but we know the trick. Whatever is being squared is what gets attached to x in our binomial that's being squared. So really all we've got to do then is just reverse all this stuff. On the other side, we've got y plus 22 divided by negative 2 plus 25 fourths, right? So to get y by itself, first we're going to subtract 25 fourths from both sides. So that gives us the quantity x plus 5 halves squared minus 25 fourths. Now we got to undo dividing by negative 2. So we're going to multiply each side by negative 2. And that's going to give us, we get cancellation, right? So that's going to give us y plus 22 equals, when I distribute this to both terms, I'm going to get a negative 2 times this quantity plus negative 2 times that number. So negative 2 times the quantity x plus 5 halves squared. Negative 2 times negative 25 fourths, let's make that a 1 on the bottom. Well, that's just going to give us positive 50 fourths, which is positive 25 halves, or I could just cancel the 2 and the 4 and make that a 2 on the bottom, right? Cross cancel. And then finally, I'm going to subtract 22 from both sides. And that gives us, we'll call that f of x equals negative 2 times the quantity x plus 5 halves squared. And then 25 halves, let's just do a little side math here. So we get 25 halves minus 22 would be minus 44 halves, right? So that gives us negative 19 halves. No, negative 19 halves, right? Yeah. Okay. There you go. So now you know that this is in vertex form. I know that h is -5/2 and k is -19/2. All right, do we need to do this? Why not? We'll do one more. You guys, you can choose to watch this or not. You may or may not need it. We'll go through one more. So, yeah. So we set it equal to y. Now we got to get an x squared plus bx on the right side, so we're going to subtract 5 from both sides. Okay, now I've got to undo multiplying by 1/5 to get an x squared on the right side. So that means I'm going to multiply each side through by 5, which is going to give me, and that's so easy to distribute, why not? So I get 5y minus 25 equals, when I distribute, I just get x squared plus 4/5 x. Okay, so we got x squared plus bx. B is inconvenient, it's a 4/5, but that's all right, just a fraction. So we end up then with, we recognize that b equals 4/5. So b over 2 is the same thing as b times 1/2, which is 1/2 times 4/5, which is 2/5. So there's my b over 2. Okay, so I've got to add b over 2 squared, so 2/5 squared to both sides. So we know on the right side, what's on the right side? This is going to factor into x plus positive 2/5 squared. On the right side, we're just going to get 5y minus 25 plus 4/25, right, when I square that out. So if let's go ahead and just combine these to make one big fraction, right? So then we're going to get 5y minus, we could change this into a minus, it wasn't big, huh? So I'm going to have to multiply this by 25 over 25 to get a common denominator. So I'm going to get, that's going to be a minus 6/25 25ths plus 4/25 is going to give us negative 6/21 25ths, just a number, equals the quantity x plus 2/5 squared. So I'm going to add this fraction to both sides. Which gives me 5y equals x plus 2/5 squared plus 6/21 25ths. And then finally, I'm going to divide by 5, but this time, instead of dividing by 5, being as we're going to have to distribute anyway, let's just think of that as multiplying the right side by 1/5, right? And so that seems to me a little easier way to think about it. So we end up with y or f of x equals, if I distribute this, I'm going to get a 1/5 times the quantity x plus 2/5 squared plus 6/21 25ths times 1/5. I just multiply straight across and get 6/21 125ths. Okay? And that's our final answer. Okay? How could I check this on Desmos? I just want to make sure I did this right. So one way I could do this is, well, I could do negative b over 2a, right, for h. So I'm going to get negative 8 divided by 2/5 is negative 8 times 5/2. So that's 40, what's that give me? Oh, is that right? So I'm going to get, let's do this real quick. So I get negative 4, no, I said 8, negative 4 divided by 2/5 equals negative 4 over 1 times 5 over 2. And that gives me negative 10. That's not what I got. What? What did I do wrong here? Something's not right. Oh, here's what I did wrong. Right here, this what I was doing. Look, I 5 times 4 is not 4/5 x. It's 20x. So this one got completely, you know what, I'm just gonna start this over. This whole thing got messed up. Let's do this. So everything from here down. All right, back to business. Okay, see if I can not be so dumb this time. So if I distribute that 5 to both sides, we end up with 5y minus 25 equals x squared plus 20x. So this is going to be a lot easier, isn't it? So then we end up with b equals 20, b over 2 equals 10. So I'm just going to add 10 squared, which is just 100 to both sides. And we end up with 5y plus 75 equals x plus 10 squared. Subtract the 75. Multiply each side by 1/5. And we end up with, call that f of x equals 1/5 when I distribute 1/5 times the quantity x plus 10 squared minus 15. 1/5 times 75, same as 75 divided by 5. So there's my answer. See if that works a little better. So yeah, so we get h is equal to negative 10, which is right. I get x minus negative 10 squared. And then k if I plug negative 10 in, I'm just going to get 1/5 times negative 10 squared is 100 plus 4 times negative 10 is negative 40 plus 5. So I get 20 minus 40 is negative 20 plus 5 equals 15. So, negative 15. You get negative 20 plus 5, so that's negative 15. So yeah, it works. Everything checks out, finally. All right, well, you saw an example of a wrong turn. All right, so the assignment will fall.